Hello, today we will learn how to solve a second-order initial value problem. The problem is 12 times the second derivative of y plus 5 times the first derivative of y minus 2y minus 2y equals 0. The first step is to transform this second-order initial value problem into a quadratic equation problem that we can easily solve. If we assume y is e to rx, we can see that the first derivative of y is r times e to rx. The second derivative of y is r to the second times e to rx. Here we assume that e to rx is different from 0. Let's replace in the above equation. So we have 12 times r to the second e rx plus 5 times r e rx minus 2 equals 0. Two ERX equals 0. If we divide each term by ERX, we get the equation 12 r to the second plus 5 r minus 2 equals 0. Because we're dividing by e to rx, we need erx to be different from 0. The next step is to solve the following quadratic equation. 12 r to the second plus 5r minus 2 equals 0. If you remember, a quadratic equation is ax squared plus bx plus c equals 0. And the formula for delta is b squared minus 4ac. In our case, a is 12, b is 5, c is negative 2. So delta will be equal to 5 squared minus 4 times 12 times negative 2. Delta is equal to 25 plus 96 which is equal to 121, which is actually 11 squared. The general formula for the roots for our generic equation would be x1 equals negative b plus square root of delta over 2a, and x2 equals negative b minus square root of delta over 2a. So for our equation here, we will have r1 equals negative 5 plus square root of delta is 11. Square root of delta is square root of 121, which is equal to 11 plus 11 over 2 times 12. And we get 6 over 24, which is equal to 1 over 4. R2, our second root, will be negative 5 minus 11 over 2 times 12, which is equal to negative 16 over 24. We divide both by 8, we get 2 and 3, it's negative 2/3. We know that the general solution is y equals c1 e to 1/4 x plus c2 times e to negative 2/3 x. We know that y at 0 equals 1, and the first derivative of y at 0 equals negative 1. We will use this information to solve for c1 and c2. y0 equals c1 e to 0 plus c2 e to 0. Any number to 0 is 1, so this gives us c1 plus c2, and it equals to 1. First derivative of y, 0, c1 times 1/4 times e to 0 plus c2 times negative 2/3 times e to 0. So we get 1/4 c1 minus 2/3 c2 is equal to negative 1. So the new equation we have to solve is c1 plus c2 equals 1, and c1 over 4 minus 2c2 over 3 is negative 1. the system of linear equations, and we will solve for C1 and C2. So C1 plus C2 equals 1. 1/4 C1 minus 2/3 C2 equals -1. From here, we can see C1 equals 1 minus C2. I'm going to replace this in the second one. 1/4 1 minus C2 plus C2 equals 1. So, so 1/4 1 minus C2 minus 2/3 C2 equals -1. 1/4 minus C2 over 4 plus 2/3 C2 equals -1. And we do 1/4 multiplying 3 multiplying 4 minus 3 C2 over 12 minus 8 C2 over 12 equals -1. -11 C2 over 12 equals -1 minus 1/4 minus 3 times 12. -11 C squared is -12 minus C2 equals 15 over 11. So C1 equals 1 minus 15. And C2 C1 equals 1 minus 15 over 11, which equals -4 over 11. So having all these values, we had y x equals -4 over 11 e to x over 4 plus 15 over 11 e to -2 x over 3. And this is our unique solution.